All right, welcome back to our third lesson. The first two lessons were about perfect squares, perfect cubes, and cube roots, square roots. We are going to use or apply the knowledge that we learned, and we're gonna see some applications of what we can do with perfect squares. Okay, um, and this will ultimately lead to the Pythagorean theorem. Okay, now first thing that I would like to talk about is actually triangles. Recall, I don't know if you remember this, but let's say here's a triangle and this is 90 degrees. Okay, so we call this a right, well, this is a right angle, right? 90 degrees is what we call a right angle. This is a right angle. So when you have a triangle with one right angle, this is called a right triangle. Okay, so this is a right triangle. Okay, this is a right triangle. Now, a triangle consists of three sides. Okay, they do have names. This longest side, okay, that is opposite from the 90-degree angle. This, okay, you can see that's the side opposite from 90-degree angle. This is what we call a hypotenuse. Hypotenuse. Okay, the other two sides are, well, we simply call they are the legs of this triangle. Okay, so the other two sides are legs. The longest side, or the side that is opposite from 90 degrees angle, is called a hypotenuse. Okay, so again, we have two legs and one hypotenuse, and that will make up a right triangle. Okay, so that's the well, I guess the introduction to a right triangle. Now, what are we going to do with the right triangle? Okay, so what we're going to do is, well, let me draw another right triangle here. Okay, this obviously is not drawn to scale, or nor the perfect triangle here. But what I'm going to do is, I'm going to say, let's say this is length 3, and again, this is not drawn to scale, and let's say this is length 4. And what I'm going to do now is I am going to draw, I'm going to take this side, okay, and I'm going to draw a square using that side length. So here, this is 3, so to draw a square, I draw a length 3 here, a length of 3 here, and a length of 3 here. So, well, if that's length 3, this would also be length of 3. So then what would the area of this square be? Well, the area, recall, is for the square is equal to the length times the width, which in this case is just 3 times 3, right? Because they are the same thing. So this is 9, right? So this is a perfect square, right? It's a perfect square because it's 3 times 3. I'm going to do the same thing with this side. Okay, I'm going to do the same thing with 4. Now, if I use this side length 4 and create a square with side length 4, then I get, maybe make it a little bit longer, and I get something like this. Okay, so this is 4 by 4. So the area here is going to be 4 times 4, which is 16. I'm going to give a unit square, right? Square units. It's okay. Okay, so that's what we have. What's interesting is, if this is a triangle with legs, with the length of the legs being 3 and 4, the hypotenuse side would actually end up with the length of 5. Now, if we do the same thing here and draw a square, okay, with length of 5, so this is 5, and this is also 5. The area here is 5 times 5, which is 25. Okay, so here is 9, here is 16, and here's 25. Is there a relationship between those three numbers? Obviously, if I ask that question, that means there is a relationship. Okay, hopefully you see it. 9 plus 16 is equal to 25. Okay, so this is telling us the sum, okay, when we add the numbers, okay, the sum of the squares of the legs Okay, so you can see this 9 came from 3 squared. This 16 came from 4 squared. So the sum, which is the addition, of the square of the side lengths would actually equal to the square of the hypotenuse side, right? Because this 25 came from 5 squared. Okay, so notice this is one of the legs squared. This is the other leg squared. When you add them together, it actually gives you the hypotenuse squared. And this is Pythagorean theorem. Okay, when we take the square of one leg, add it to the square of the other leg, when we add them together, it actually equals to the square of the hypotenuse side. And this, again, is what we call Pythagorean theorem. And this is actually significant. This was, well, I guess you would imagine this Pythagorean theorem, you know, the name is coming after Pythagoras. I don't think he discovered, this theorem. Maybe he did, I don't know. You know what, I didn't study history of math. But this discovery was for sure a huge, very significant, okay, to whatever we do now, actually. This is the basis of trigonometry. Trigonometry, which you will learn more in Math 10 and Math 11 and Math 12. Okay, but Pythagorean theorem is really very, very significant. And I will put some links in the description so you can actually see the applications of Pythagorean theorem in, well, I'm a sports fan, in actually basketball, baseball, football, you name it, okay? But I'll put some links so you can take a look how Pythagorean theorem could be used in those sports. I will show you one more example. Otherwise, I think that's it, really. That's it for today, is to introduce you to Pythagorean theorem. Okay, so let me just show you another one. Let's say we have a triangle. Let's say with, well, I guess I'll do it like this. If we have a square here and a square here, well, that's not really a square. And we can actually figure out this area. Okay, this is 90 degrees. Okay, so I am gonna go with, if this is 5 and this is 12, 12. Then what would this side length be here? Okay, now again, we can use this drawing here. We can then see the area of this square with side length of 5. This is going to be 25, right? Because this came from 5 times 5. And for the other leg, the area of this square is going to be 12 times 12, which is 144. So given that's the case, we know the area of this third square, the square that came from the, or made from the hypotenuse side, is going to be the area of the largest square is going to be 25 plus 144. This is 169. So we know this area will be 169. Again, that came from 25 plus 144. It's just the sum of the other two squares. Okay, the hypotenuse, let me call it hypotenuse square. Okay, the hypotenuse square is always the sum of the legs squared. Okay, so then how does this help me with finding out this hypotenuse side, I guess? Well, if you think about it, or if you just list out all the perfect squares, like 1 squared, 2 squared, blah, 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 blah. Let's say 11 squared, 12 squared, and 13 squared. If you list them out, that's 1, that's 4, and blah, blah, blah. This is 121, 144, and 13 squared is actually 169. So then we can tell this is actually 13. for the length of the hypotenuse. Okay, again, based on the Pythagorean theorem. Okay, so that's it for this short lesson. Basically, just the introduction to the Pythagorean theorem. Again, I will put down some links in the description so you can check some applications of Pythagorean theorem in sports. Okay, enjoy!